Hi students, as a part of corrosion controlling methods, today I am going to discuss with you about the last method of corrosion controlling, that is electroless plating. So the name is self-explanatory, that is, this is the method which will not use any sort of electricity, right? Electroless plating, that is plating the metal or coating the metal on the surface of the base metal without making use of electricity is nothing but electroless plating. Instead, if you use the electricity for coating or plating the metal, then it is called as electroplating. So that is the basic difference between electroplating and electroless plating. So actually electroplating is also important from the knowledge point of view, but it is not there in the syllabus. That's the reason I am not going to explain you about the electroplating. Now that is the simple definition of electroless plating. Now coming to the actual definition or precise definition or the process involved. What is the exact process involved in the electroless plating? So this particular method involves the coating of noble metal. Coating of noble metal on the pre-activated surface of the base metal, making use of reducing agent without using the electricity or without using electrical energy. Now you have come across the word, two words. The one is the noble metal here, and the second one is the pre-activated surface. So what do you mean by pre-activated surface? I will discuss later, but what is noble metal I will discuss. So the metal which will act as cathode with respect to the base metal is nothing but the noble metal. Now what is the base metal? Already you know. The base metal is the one whose corrosion is to be avoided or prevented or controlled. Now coming again, what is electroless plating? The process of depositing the noble metal on the pre-activated surface of the base metal with the help of the reducing agent without using the electrical energy. Now the overall process involved in the electroless plating can be illustrated by the following reaction. That is, what we need to do in this electroless plating is we have to take the noble metal ions. That is, we have to take the salt comprised of noble metal ions, and this noble metal ions which are a part of the noble metal salt should be treated with the reducing agent. Now what are the metal ions here? The metal ions of the noble metal. So what we need to do is we have to take the salt of the noble metal. That is the salt of the noble metal ions, and it should be treated with the reducing agent. Now what do you mean by reducing agent? Reducing agent is a substance which reduces the other, thereby itself undergo oxidation. Now what it will do? It will reduce the noble metal ions which are present in the noble metal containing solution on the surface of the base metal. Now what will happen to the reducing agent? It gets oxidized. So whenever it is getting oxidized, definitely we are going to get the oxidized product also. Now the reduction of the metal ion, the reduction of the noble metal ions takes place on the surface of the base metal. Now let us say that this is the base metal. Now the reduction of the metal ions, noble metal ions, takes place on the surface of the base metal under the influence of this particular reducing agent, by which the coat of the noble metal ions will be developed on the surface of the base metal. And already I have discussed the reducing agent is the one which reduces the other, thereby itself undergo the oxidation. So definitely we are going to get the oxidized product. So we are going to get even the oxidized products. Oxidized products. So this is about the general reaction involved in the electrolysis plating. So what is the exact process involved in the electrolysis plating? I am going to discuss with you by considering one of the most familiarly used electroless plating method, that is electroless nickel plating. So electroless nickel plating. So it is the most widely used electroless plating method. Now let us see what is the process involved during this particular electroless plating or electroless coating method. Now, whether the process is either the electroless nickel plating or any of the electroless plating, so first and foremost, we have to prepare the composition bath. So, we have to prepare the composition bath into which we have to dip the activated base metal. What do you mean by activated base metal? I will discuss that. So, do remember that the first and foremost step involved in any of the electroless plating method, whether it is electroless nickel plating or any of the electroless nickel plating, is we have to prepare the composition bath. We have to prepare the bath. Now, in order to prepare the bath, we have to consider some of the ingredients, and we have to consider the calculated amount of the ingredients. So how much amount we want, we cannot take that. So we have to take the ingredients in the calculated amount only. Now let us see what are those ingredients which are required for the electroless plating, and what is the quantity of each and every ingredient which is a part of the composition bath into which our base metal is going to be dipped or immersed. So first, already we know that we have to take the salt comprised of the noble metal ions. Now the salt comprised of the noble metal ions. So what is the noble metal ions in the electroless nickel plating? Nickel. So nickel is the noble metal. So since it is a noble metal, so definitely we have to take the salt in such a manner that it comprises the nickel metal ions. Now, what is that salt which comprises the nickel metal ions? The salt which comprises the nickel metal ions is nothing but nickel chloride salt. So we have to take the nickel chloride salt. Already I have discussed that we have to consider the calculated amount of each and every ingredient during the preparation of the composition bath. Now the quantity of the nickel chloride should be taken is 20 gram per liter. 20 gram per liter. So we have to prepare the nickel chloride solution by dissolving 20 grams of nickel chloride in 1 liter of water. 1 liter of distilled water. And what is the purpose of this? What is the function of this nickel chloride? It is a coating solution. Already have discussed that it is the one which comprises the noble metal ions, that is Ni+2 ions, which are going to be coated or deposited on the surface of the base metal. Coming to the next important ingredient, that is the reducing agent. Right. So the reducing agent which is mainly used during this electroless nickel plating is the sodium hypophosphite, NaH2PO2, sodium hexophosphite, sodium hypophosphite, and the amount of sodium hypophosphite which is being used during the electroless nickel plating when the coating solution nickel chloride is being used is 20 grams per liter. And what is the purpose of reducing agent? Already I have discussed. This is the one which reduces the noble metal ions which are a part of the coating solution, and this reduction of the noble metal ions takes place on the surface of the base metal, forming the coat of the noble metal on the surface of the base metal. So the next ingredient which is supposed to be considered during the preparation of the bath is sodium succinate. Sodium succinate, and its amount should be 15 grams per liter. So here also the water is used as a solvent. And what is the purpose of the sodium succinate? So There are two purposes associated with the sodium succinate. It acts as complexing agent as well as it acts as exaltant. So what do you mean by complexing? So it is the complexing agent. So the purpose of this complexing agent, sodium succinate, in this particular bath is it will bind all the other ingredients together. That is, it will bind the nickel chloride salt, sodium hypophosphite, sodium acetate with all the other ingredients along with this particular sodium succinate. So it is a binding agent. So complexing agent or binding agent. So not only that, it will act as the exaltant. Exaltant means it is a stimulator which will stimulate the reaction between the coating solution and the reducing agent. So it acts as a stimulator as well. It stimulates. Stimulates means what? Which will encourages the reaction between the coating solution salt and the reducing agent. Now, do remember that in the case of this particular method, nickel chloride salt is being used as the source of the noble metal ions, and the sodium hypophosphite is being used as a reducing agent. So there is a need to facilitate the reaction between these two in order to coat or deposit the nickel ions on the surface of the base metal. Now, in order to facilitate the reaction between nickel chloride, which is a source of the noble metal ions, and the sodium hypophosphite, which is a reducing agent, we need to maintain the pH of 4.5. So whenever we maintain the pH of 4.5, then only the reaction occurs between the coating solution nickel chloride and the reducing agent. And in order to maintain the pH 4.5, we have to use sodium acetate. Sodium acetate as a buffer solution. Now, what is a buffer solution, student? The solution which maintains the pH of the solution is nothing but the buffer solution. Now, here the buffer solution is the sodium acetate, and it will maintain the pH at 4.5 and its quantity should be 10 grams per liter. 10 grams per liter. Right. And not only that, apart from this, we have to maintain the temperature during this particular electroless plating. That is 93 degrees centigrade of temperature should be maintained inside the bath in order to facilitate the reaction between the reducing agent and the coating solution. I hope you understood this. Right. So after preparing the bath, what we need to do is we have to activate the base metal. We have to activate the base metal. Now, what do you mean by activation of the base metal? Activation is nothing but the removal of impurities from the surface of the base metal is nothing but activation of the base metal. Right? So this can be done by using suitable solvent or alkali, that is the base, followed by acid treatment. That is, degreasing of base metal is done by either suitable solvent or alkali. Alkali is nothing but the base followed by acid treatment. Now the base metal will become free of all the impurities. Now whatever the base metal which is now free of all the impurities is considered as the pre-activated base metal. Now this pre-activated base metal should be dipped or immersed into this composition bath. So now, composition bath comprises coating solution, nickel chloride plus reducing agent. What is that reducing agent, students? The reducing agent is sodium hypophosphite. Along with that, sodium succinate should be used. What is the purpose? Already discussed. And sodium acetate is also used as the buffer solution in order to maintain the pH 4.5 in order to facilitate the reaction between the coating solution and the reducing. So now what we need to do is we have to dip our base metal. We have to dip our base metal whose corrosion is going to be prevented or avoided or controlled. Pre-activated. Pre-activated. What do you mean by pre-activated? Already I have discussed. Pre-activated base metal should be immersed into it. Right. So now, whenever the pre-activated base metal is immersed into the composition comprised of the nickel chloride, which in turn comprises of the noble metal ions, Na+2 ions, and the reducing agent sodium hypophosphite, the sodium succinate, which is a complexing agent, as well as the exaltant, and sodium acetate, which is the one maintaining the pH 4.5 in order to facilitate the reaction between the coating solution and the reducing agent. The following reactions takes place. Following reaction takes place. So already I have discussed that reducing agent is a substance which reduces the other, thereby itself undergo oxidation. So sodium hypophosphate is the reducing agent, and since it is the reducing agent, it reduces the Na+2 ions which are a part of the coating solution, that is nickel chloride. But what will happen to it? It will oxidize. It will oxidize in the following fashion. That is H2PO2 minus, which is hypophosphite, which is the reducing agent, will react with water molecules. Now, what is the source of the water molecules? Already I have discussed the solvent used for dissolving the nickel chloride, sodium hypophosphite, sodium succinate, and the buffer solution is the water only. So the water is definitely a part of the composition bath. Now whatever the water which is the part of the composition bath, this hypophosphite reducing agent reacts with this particular water molecules. So and the reaction of any substance with the water molecules is nothing but the hydrolysis. So based upon that, we can say that the reducing agent hypophosphite will undergo the hydrolysis process. What will happen to the reducing agent? It is reducing the nickel ions, right? It is reducing the agent. It is the reducing agent will reduce the other, thereby itself undergo oxidation. So it will undergo the oxidation to H2PO3 minus, which is dihydrogen phosphite, and produces 2 moles of H plus ions and loses 2 electrons, because this is oxidation. It is the reducing agent which is reducing the other, thereby itself undergo oxidation. That is the reason it is undergoing oxidation by reacting with the water molecules, which is a solvent which is being used to dissolve all the ingredients which are considered for preparing the composition bath. Right now, whatever the 2 electrons which have been lost by the sodium hypophosphite are gained by Na+2 ions which are present in the coating solution. So Na+2 ions are present in the coating solution. Na+2 ions are present in the coating solution, that is nickel chloride. It will gain 2 electrons which have been lost by the reducing agent hypophosphite and gets reduced to nickel solid. That is what happens is. So let us say that this is the pre-activated base metal. Now, whenever it is dipped into the composition bath, what happens is, initially what is happening, the hypophosphite is undergoing the oxidation and losing the 2 electrons. Now, which ions are present in the composition bath? The Na+2 ions are present, which are a part of the coating solution. That is, Na+2 ions are present. Now, what happens is, whatever the Na+2 ions which are present in the composition bath in which the base metal has been dipped or immersed, what will happen is, it gains the 2 electrons which have been lost by the reducing agent hypophosphite. So it will gain the 2 electrons. It will gain the 2 electrons and gets reduced to nickel solid. And this reduction of nickel, this reduction of Na+2 ions takes place on the surface of the base metal. base metal by which the Ni noble metal gets deposited on the surface of the base metal. Ni gets deposited on the surface of the base metal. So this is how the coat of the noble metal develops on the surface of the base metal under the influence of the reducing agent. I hope you understood this. Right, so this is how the nickel, which is a noble metal, is being coated on the surface of the base metal. Now this is the oxidation reaction and this is the reduction reaction, and in order to get the overall redox reaction, what we need to do, we have to combine the oxidation reaction with the reduction reaction. After combining the oxidation reaction with the reduction reaction, then we have to cancel the equivalent ions or equivalent electrons if present on opposite side of the arrow mark, or we have to add the equivalent ions and equivalent electrons if present on the same side of the arrow mark. Same side of that. So this is oxidation reaction. This is reduction reaction. In order to get the net redox reaction, we have to combine this both. Now, so equivalent ions are not present in this reaction, but equivalent electrons are present, and these equivalent electrons are present on the opposite side of the arrow mark with respect to oxidation and reduction reaction. So in the case of oxidation reaction, the two electrons are present on the right side of the arrow mark. In the case of reduction reaction, in the case of oxidation reaction, the two electrons are present on the right side of the arrow mark, whereas in the case of reduction reaction, the two electrons are present on left side of the arrow mark. So we can cancel this. So now what we need to do, whatever the portion which is remained on the left side of the arrow mark should be written on left side of the arrow mark only after cancelling this opposite two electrons, and whatever the content which is remained on the right side of the arrow mark should be written on the right side of the arrow mark after cancelling this two electrons. So what is the portion which is left on the left side of the arrow mark? With respect to left side of the arrow mark, what is the portion? H2PO2 minus plus H2O plus Ni plus 2. So giving rise to what is the portion which is remained on, what is the content which is remained on the right side of the arrow mark? H2PO3 minus plus 2H plus nickel. So now what is happening, students, in this overall reaction? In this overall reaction, reducing agent is getting oxidized to H2PO3 minus, whereas Ni plus 2 is getting reduced to Ni, and its reduction is taking place on the surface of the base metal. Since its reduction is taking place on the surface of the base metal, the coat or deposit of the nickel, which is the noble metal, takes place on the surface of the base metal. I hope you understood this video, students. So this is about the corrosion unit. Thanks for watching.